Continue the concept of one variable, one equation, but now we're going to get that equation from some sort of a statement or some sort of a problem at hand. Okay, so if the problem at hand talks about consecutive integers or angles of a triangle, or whatever it may be, we're going to take that word problem and translate that word problem into some sort of algebraic representation. Now, if we put them into equations, we can go ahead and solve. We may also just write expressions for some of them. Okay, let's take a look at this first example. And there's 5 different parts here. So all we want to do is represent the statement with some sort of a variable expression. So if you heard a number is decreased by 4. This is our easy first one to start with. A number, we don't know what that number is, but it's decreased by 4. What does that automatically ring a bell to? What do you think of right away when you hear a number, but it's decreased by 4? Subtraction. Absolutely. Right away you think subtraction. What would the expression be to represent something using h or x or whatever it is to represent that? Indigo? Yeah. X or h or m or k or whatever it is minus 4. Okay, a number decreased by 4. Not 4 decreased by some number. What would 4 decreased by some number be? 4 decreased by some number. Yeah, 4 minus h. So with subtraction, it's important that we are aware of the way the statement is written. If you hear the sum of, though, it doesn't matter, because addition is commutative. So we learn about commutative and associative, now you can see where it comes into hand. So if you hear a number, or 5 more than a number, it could be x plus 5 or 5 plus x, actually. That doesn't matter. But with subtraction, it's very important the order in which you set up your arrangement. How about part B? Part B. 8 more than 5 times a number. 8 more than 5 times a number. Will? 8 more than, good, 5 times the number. Okay, now I could also have written that as 5h plus 8. Okay, 8 more than 5 times the number. It could be 5h plus 8 or 8 plus 5h. Part C. The difference between a number and its square. The difference between a given number and its square. It's being possessed there, right? A number and its square. How would I consider that? H squared minus h. Okay, the difference, so we start with the subtraction symbol, between a number and its square. Now, technically speaking, the order of this is not obvious. The difference between a number and its square. What matters? What matters is what? Which of those numbers is what? Bigger in this case. Okay? Because technically speaking, we want to think to ourselves, well, when you square a number, it always gets bigger, doesn't it? But it doesn't actually. What's an example of when you square a number and it gets smaller? Negative 2 squared. Now that gets bigger. Negative 2 squared is positive 4. Right? It gets bigger in number. What else?
4 to the negative 7 power.
Okay, so 1 over 4 squared. So generally speaking, generalize that statement, Chandler. Give me a general statement. What numbers get smaller when you square them?
Numbers that have negative exponent.
Okay, yes, exactly, you're right. But let's use common terms. Fractions. Numbers with negative exponents really are fractions, right? Okay? So fractions can get smaller when squared. So for this one, if we want to find the difference between these two, just put an absolute value between them. So we know that depending on the order of which, we're looking at the difference between the two anyhow. How about part D? The sum of twice a number and half that number's absolute value. Part D. The sum of twice a number and half that number's absolute value. Christian, what do you think of when you hear sum?
The result of addition.
Addition. So let's start with that. Okay. Let's see. James, when I hear the sum of twice a number is what? How do you represent that? 2h. So I know I have the sum of twice a number and what? What's the other part that I have to fill in, Alex? So half of absolute value h. So the sum of, I'll point as I speak, the sum of twice the number and half that number's absolute value. Okay? So twice the number plus half the absolute value of that same number. How about twice the sum of a number and 9? Be careful here. Notice my pausing, right? The way I said it. Twice the sum of a number and 9. James? Very good. Okay, twice starts with the 2. Twice the sum of a number and 9. So we do the sum of some number and 9 and then double that value. Okay, so twice this sum right here. Some dummy variable h and 9. Questions? Questions? You definitely have this on your first test, where I'm going to give you some statements and just say translate. Okay, with x or n or h or whatever it may be. An example. Let's take a look at the second example. James, you're mentioning this one. Look at that. So James left his house and drove for t hours at 50 miles an hour towards the city. If his house and city are 200 miles apart, then how many more miles must he still drive? Well, clearly we're not going to be able to solve this, right? We're going to have to turn it into some expression. We don't know how many hours he's driven for. We know he's driven for t hours, but t is some number. So let's say hypothetically that James drove for 1 hour. How far did he go? He drove for an hour at 50 miles an hour? 50 miles. So he would still have another 150 miles left to go, wouldn't he? Let's say that James drove for an hour and a half. Well, then he would have gone 75 miles, which means he'd still have another 125 miles to go to make it to the 200 miles between the city. So to figure out how much he still has to drive, we take that total distance of 200 and subtract however far James has traveled. The problem is, how far has James traveled in this problem? We don't know how many hours have elapsed. How can I represent how far James has traveled in terms of some variable? Jeffrey? 50t. And think about this for a second. This is one of our basic equations in math. Distance equals rate times time. If we're trying to figure out how far James has traveled in distance, we say that the distance he's traveled is the rate, which is 50 miles an hour, times the time that has gone by. That's how far James has traveled. So how much is left is just 200 minus that quantity. Again, James and the city, you going to? Where is it? Yeah. And the city are 200 miles apart. So if you subtract however far he's gone, 50t, which comes right up here, from the 200 miles apart, we'll figure out how much he has left to still drive. So again, this is not a numerical answer. This is an expression that represents the answer. So what limitation do I have to this problem? What limitation? There's one limitation to this problem. Alex?
You don't know how much hours he moved?
Good. You don't know how much hours he moved. He's gone. But what's the actual limitation I'm asking? What's the restriction here? After an hour, right? He's gone 50 miles. After 2 hours, 100. Yeah. 4 is your max, right? After 4 hours, what happens? He's in the city. So he's not going to go beyond, right? His goal is to get to the city. So we could say that there's a restricted domain for t. T can only be numbers less than or equal to 4. Okay, beyond 4, James has surpassed the city and gone beyond his destination. So that's called the restricted domain. So in your answer, you could always put on the side, t must be less than or equal to 4. Okay, you'll see that sometimes in problems you do this year where you have to use common sense to dictate the restricted domain. On your own, draw yourself a diagram and try and start labeling the diagram. Okay, we have a triangle here. So go ahead and draw yourself a diagram. Start to label the diagram. That's my suggestion for any geometrical problems here. Always draw a diagram. Always. As long as you can. It doesn't say whether it's right, obtuse, acute, scalene, isosceles, nothing. So you draw whatever you want. But I wouldn't draw a right triangle so you don't, you know what I mean? Just so you don't assume that it's 90 degree angle. So just draw yourself a regular triangle. If you drew a right triangle, it really doesn't matter, just so you know. But I'm just saying, I don't want you to assume that it's 90 degree right now.
His office is locked. We're not going to find it.
After school trip. You have your homework hard copy or is that you see your homework items?
Yeah.
Good. What's something I can label in this diagram? What can I label? Well.
One angle is K.
All right. One angle is K. What else, Will?
Another angle has K over 2 minus 15.
Can you explain that, Will? So we're all clear as to where you got that?
Yeah, it says the second angle is 15 less, so that'd be the minus 15. Then half the measure of the first, so it'd be half of the second.
Very good. So if you put 1/2 K minus 15 or K over 2 minus 15, either way, that top angle, wherever you drew it, is really 15 less than half of the first angle we identified. And then step 3 says, what are we trying to figure out? Find the measure of the third angle in simplest terms. Well, what do the measures of a triangle add up to? What do the measures of a triangle add up to? Well, 180. They add up to 180. So, Alex, what kind of a statement can I write from that information?
The sum of all three angles equals 180 degrees.
Yeah, the sum of all three angles equals 180. So I could say, right, K plus K over 2 minus 15 plus the third angle. What do you want to call the third angle? Don't call it K, though, right, obviously? Jeffrey? X. All right, that works for me. Plus X equals 180. And what's our goal here? Sarah, what are we trying to do?
We're trying to find the third angle.
Yeah, which is X. So in reality, what are we just doing? Solving for X. So go ahead and collect your terms. Collect terms here. K plus half a K is K plus half a K. Danielle? 3/2 or 1.5K, either way. Minus 15 plus X equals 180. I next want to get rid of the 15. How do I get rid of the 15? James? All right, so I got 195 on the right-hand side now. Now I want to solve for X. Who remembers from yesterday's lesson? If you want to solve for a variable and there's other variables involved, how do you approach this? How do I isolate X if this is my current situation right here? Sarah? Yes. Think about K as if it's a number. If K, or even 3/2 K, if this was a number like 8, you would subtract 8 from 195. So subtract 3/2 K from 195. And there's the third angle. Okay? Notice, have we gotten any numbers? Not yet, right? Not yet. Everything's in terms of expressions right now. We haven't actually solved any of these. All expressions, all expressions. Questions on this problem? Let's take a look at example 4. And I always say tricky because sometimes students make minor mistakes in here which cause problems. This, by the way, is a great example of an SAT problem. On the SAT all the time. 5 consecutive integers, or 5 consecutive odd integers, or integers that are multiples of 3. So, n plus 3, n plus 6, etc. This kind of a problem shows up all the time. So in terms of m, what is the sum of 5 consecutive even integers if m is the fourth integer? If m is the fourth integer. Give me an even integer, Christian. 2. So if the number 2 is our even integer, what's the next even integer? Then 8, etc. Right? How much does each integer differ by? 2. What if this had been a statement that said odd instead? I would go 1, 3, 5, 7, 9, right? How much would they differ by still? 2. So they still differ by 2. Is that clear? So the words odd or even have no significance except for the fact that the integers differ by 2. If it didn't say even or odd, if it just said 5 consecutive integers, it'd be n plus 1, n plus 2, n plus etc., etc. So if the fourth integer is m, let's put an m right over here, in like the fourth spot. We'll put 5 spots maybe on the board. Okay, here's fourth spot, fifth spot, third, second, and over here first spot. Okay, we got 5 spots. If m is the fourth integer, what's the fifth integer, Jeffrey? If m is the fourth? m plus 2. Because the next consecutive even integer is 2 greater than that one. So it's got to be m plus 2. And as Christian said, if m was 2, well, 2 plus 2 gives you 4. That's the next consecutive even integer. How about the other direction? How about the other direction, Anigo? M minus 2. Because that's 2 less than the fourth consecutive even integer. And Daniela, what about the other 2? Very good. Okay, we have m minus 4 and then m minus 6 on the far left. Question so far on this one?
So that's all it's asking for?
Well, it just says the sum. So what are we going to do?
Oh, you're gonna
Yeah. How many m's do we have, everybody? 5 m's. The 2 and the negative 2 cancel, leaving a negative 10 behind only. Right? Sum up all the integers or the constants. These numbers, this 2 and this negative 2 cancel right here. Negative 4, negative 6 is negative 10. So we've got 5m minus 10. So had this said odd, there would have been absolutely no difference in the problem if it had said odd instead of even. Okay? What if it hadn't said odd or even? What would the answer have been? What if it didn't say odd or even? What would the answer be?
5m minus
5m minus?
2. Plus, no, minus 2.
Not minus 2.
5m minus 5.
5m minus 5. Let's go over that real quick. So, if this weren't the case, if it was, instead of saying even, right? It just said integers and they're consecutive. This is m. This is m plus 1 now. This is m minus 1, m minus 2, and this would be m minus 3. The plus 1 and the minus 1 cancel, giving you a minus 2 and a minus 3, which would have just changed that to be a minus 5. Okay, had not said even or odd in this problem. Okay? All right. This next one's a little bit tricky because at first it might seem like a physics problem, like a very elaborate, but we'll see how it can be more of a math problem than a physics problem. So a train leaves town traveling 50 kilometers an hour east. Right? So this train is literally here and is traveling east. I know it's like this in the city, but for you, let's consider right east and left west. Next, another train 3 hours later leaves traveling faster. What's going to happen eventually if that train is traveling faster? What happens? Yeah, they're either going to hit each other or hopefully they're on 2 different tracks. And maybe it passes the other one. Okay? Oh, actually it says on the same track. So I guess this question is when will it hit the other one? I didn't even think about it, the wording. So how long will it take the second train to catch up to the first, or, rear end the first train, really, if it catches up to it? So we have to think about this problem. There are 2 ways to do it. There are 2 ways. There's an algebraic solution, and then there's a more of a inspective solution, by looking at the problem, by understanding the nature of the problem. So there are 2 ways. I'll start with an algebraic approach first. We'll do that. And then I'll show you how you can kind of also do this without an algebraic approach. But I want you to understand the algebraic approach in case I ask you for some representation. So a minute ago, I gave you a formula that relates distance, rate, and time. What was it? What was the formula? D equals RT, okay? Distance equals rate times time. Now, that is a general formula for anything that is moving at a constant rate for a given time period. So as a result, we can take a look at this and say, well, let's identify the first train. First train. How fast is the first train traveling? Well, all right, so there's the first train, right? Oops. How about the second train? How fast is it traveling? How fast is the second train traveling? Emily? 75 miles an hour. I'm going to call this T2 and D1 and T1 just to specify for now. Give yourself subscripts, please. Subscripts only indicate the second particle or train or whatever the thing that's moving is, object. So this is the first scenario, this is the second scenario. How are the times related? How are the times related? Like if train 1 is traveling for 8 hours, how long has train 2 been traveling for? If train 1 is 8 hours, train 2 is traveling for? So it's how many hours less than train 1? 3 hours less than train 1, right? So why don't I do this? Why don't I rewrite statement 2, but instead of putting T2, what can I write as an expression to represent T2 in terms of T1? Jeffrey? What is it? Yeah, T1, but T minus 3. T1 minus 3 hours. Because it starts 3 hours later, right? It starts 3 hours after the first train. So again, if the first train is going for 15 hours, the second train is going for 12 hours, which is 15 minus 3, which is 12. Why did I do this now? Right? What the heck was I thinking? Why did I do that? There's a reason. That's just arbitrary. You had a hand at it, maybe?
I mean, you're trying to solve for T.
I'm trying to solve for T, good. And before that, I had T1 and I had T2, didn't I?
So now you have the same T variable.
Yeah. Remember a minute ago, I had 2 different variables, T1 and T2. They were different things. Now I've got everything in terms of T1. But the problem is I still have 2 equations here, don't I? What else do I know? I know one more piece of information that I haven't used yet. Why don't 2 people come up and demonstrate this? It'll be very obvious once you see it. Who wants to volunteer? Come on. All you got to do is walk. Perfect. Will and Sarah. Perfect. Come on up. So, let's do this. Sarah, you start first. Go at a rather slow pace, maybe like a half a step every second. Will, wait 3 seconds, and then go a little bit faster. Okay? But Will, your goal is you need to catch up to her before you get to the podium. Okay, so don't go too fast, but fast enough that you catch up to her. As soon as you catch up to her, though, both of you stop. Okay, Will, start going. Keep going, catch up, and stop, both. Okay. Didn't they both start right here? So haven't they both traveled the same distance? So what can I do now? What can I do? D1 is equal to D2, right? Because you traveled the same distance as she did in order to catch up to her, just at a different rate. Thank you, guys. So as a result, D1 and D2 are identical. So I could set the equations equal to one another. Remember, who was it that mentioned the transitive property, I think, last week? We were talking about transitive property. This is the transitive property. If you both travel the same distance and D1 is equal to D2, you could set those expressions equal to one another. Let's go ahead and do that. So we could say 50 T1, which is this expression for D1, is equal to D2. 75 times T1 minus 3. So what we've done is we've eliminated all these extra variables that were not necessary in the problem. We used our context clues, the fact that it has to catch up to the other one and thus they travel the same distance, to set those 2 things equal. And now what could you do? Yeah, go ahead and distribute and solve. could probably do this one in your head. If you think about quarters, like quarters, you know, when you pay money with quarters, what does T1 turn out to be? Good. 9 hours. So after the first train, after Sarah started walking, it's 9, in our case, seconds, right? We did seconds. But 9 hours have elapsed before Will caught up to her. So Will, how long did you go for then? If she went for 9 hours, how long did you walk for? Or 9 seconds, whichever. You're the second train, right? How long was the delay? How long did you wait?
3 hours.
Yeah, so instead of 9 hours, you traveled only 6 hours. Okay, the second train waited 3 hours to go. And the question is, how long will it take the second train to catch up? So this is not our answer. Right? This is not our answer. This is how long Sarah's train, her in her conductor hat, you know, operating her train, she's been going for 9 hours. But Will didn't start for another 3 hours. So how long did it take to catch up? 6 hours it took to catch up. Okay, and I used the representation from earlier. Take a look, I'll point. Remember we replaced T2 with T1 minus 3? That was like a let statement. We said let T2 equal T1 minus 3 from the problem. So T2 is the same as T1 but minus 3. 9 minus 3 gives you 6 hours. Now, another way to figure this out. Another way to figure it out. Let me think. Okay, here's another way to figure it out. Sarah, how fast were you traveling in the beginning? You remember your train? All right, 50 kilometers an hour. So after 3 hours, how much of a head start does Sarah have? You know what I'm getting at right now? Okay, hold on for a second. How much of a head start does Sarah have after 3 hours if she's traveling at 50 kilometers or miles per hour? 150 kilometers or miles, whatever it is. So she's got a head start of 150, right? How much faster than her are you traveling? What's 150 divided by 25? 6 hours. Every hour, Will is gaining 25 miles, isn't he? Every hour you're gaining, because she's only traveling 50 miles an hour, you're traveling 75. So every hour that elapsed, you gain another 25. Until you've gained that full 150 back that she got a head start from, that would take 6 exact hours. Now, the algebraic approach is easy because, not easy, is more powerful because this is easily, divisible and stuff. It makes it very simple because it worked out that way. But when the problem gets a little more complicated, you're going to need an algebraic approach. Okay, so having the distance equation, setting them equal works, but also using common sense. If it's the SAT and it's multiple choice, and you can get the answer by doing it the way I showed you the second way, do it, for sure. Because it takes a lot less time, doesn't it? Think about the fact that he's gaining 25 miles every hour, and she had a 150-mile head start, or kilometers, whichever unit it is. All right. All right. So, Chandler, why don't you read for us, nice and loud, please.
Decide to go for a jog from your house and run south and park at a rate of 8 miles per hour. An hour later, your brother also left home to go for a jog that runs north and park at a rate of 6 miles per hour. How far apart are you after double your hours have gone by since you left home?
Okay, so after you left home, not after your brother left home. So draw yourself a quick diagram first. Draw yourself a quick diagram. You decide to go for a jog and run south on Park. So let's say here is the starting point. You run south on Park at a rate of 8 miles per hour. An hour later, your brother also left home but runs north on Park at a rate of 6 miles per hour. After W hours have gone by, what is W? W is some variable, we don't know. After some amount of time has gone by, how far apart are you guys? So just think logically for a second. Go one step at a time. After the first hour has gone by, how far apart are you and your brother? After an hour has gone by, how far apart are you and your brother? Since you left, obviously. An hour after you left, how far apart are you guys?
14 miles.
Careful. Careful. I understand where that comes from, Chandler, but don't forget one piece. Your brother doesn't start at the same time as you, does he? Want to
So, wait, his brother, oh, he's, an hour after, 22.
22. That's after 2 hours, yes. After 2 hours, it'd be 22. Remember, the first hour, only the person running at 8 miles an hour is running.
Oh, so 8.
So 8, yeah. So ready? Time equals 0. Ready? You start the stopwatch. So I'm running down South Park Avenue, 8 miles an hour. An hour is elapsed. I've traveled 8 miles. If you're running 8 miles an hour, it's a decent pace, you know. You're running like a little under a 10-minute mile for sure. So you run 8 miles in an hour. Then your brother starts. Okay, so after 1 hour, once you've hit that first hour or 8 miles, your brother then starts, and you're still moving. So after the second hour, as Chandler mentioned, you have 8 for the first hour. In the second hour, you move another 8, he moves 6, so it's another 14, plus that 8 is where Chandler got 22 a minute ago. So think about this as a table of values, if you like. Okay, time being here, and distance apart, okay, being here. After an hour, you're 8 miles apart. After 2 hours, you're 8 plus another 14 because you both traveled now. So you're 22 miles apart. After a third hour, you're another 14 miles on top, which would be 36 miles apart. What you'll notice is that after that first hour, everything's going up by 14. Where does the 14 come from again? Where's the 14, Jeffrey? 8 plus 6. If two things are moving in opposite directions, you could just add their rates together. Think about it. If I'm walking away from you, and you're walking away from me, the distance between us is growing much greater than as if I just move myself. If I just walk away from you and you're standing there, the distance is growing. But if we both walk away from each other, that gap between us is expanding at a faster rate. Therefore, every hour, after the first hour, we're traveling at 8 miles an hour. Everything else, the gap is splitting by 14 miles an hour. So, yeah, it seems like it's easy after 3 hours, but it doesn't say 3 hours, does it? It says after W hours have elapsed. After W hours. So, how could I represent the distance traveled by you, by this person right here? The distance traveled after W hours. How far has that person traveled after W hours? Yeah, so D equals RT. Again, this is how far the first person, meaning you're running, you ran for 8 miles an hour for W amount of hours. But your brother ran for an hour less than you, didn't he? He was lazy, he was sitting at home watching a TV show, and he said, you know what, I'll start an hour later, and then I'll jump in. So how far has your brother traveled after W hours have occurred for you? Not for him, but after W hours have gone by for you, how far has he traveled now? How far has he traveled now? If you're having trouble understanding, let me rephrase this. Give me a second, I see his hands. If you have gone for 7 hours, your brother has run for 6 hours. If you have run for 10 hours, your brother has run for 9 hours. Okay, time-wise. So now think of W. So how far has your brother traveled? If you've traveled AW, what's his distance traveled?
I mean, this might not apply the first hour, but it would be D equals 6 W minus 6.
Close, not mine. Oh, okay. Did you say parentheses or no?
No.
Without parentheses, you're correct. 6W minus 6. That's fine. But what was I about to write? Anyone know? Sarah? Yeah, you just distributed the 6, right? Because you subtracted that extra 6 miles. Didn't you? Is that what you thought of it as? That works perfectly. I thought of it as, well, you're traveling for the same amount of time, but 1 less hour.
Yeah, but for the first hour, it doesn't apply because he hasn't traveled. I mean, my equation, but yours does.
No, they both work fine. You can use 6W minus 6 for the distance traveled by your guy. The minus 6 is saying, you know what, I didn't travel 6 miles in the beginning because I didn't run that first hour.
But for the first hour, wouldn't that mean that he ran, if we're going by like the other person's time, wouldn't that mean that he ran negative 6 miles since he didn't?
You're right, but think about it this way. If I put a 7 in here, what's 6 times 7?
42.
42 miles, right? But you didn't run those first 6 miles, so this distributing tacks off the 6 from the beginning already. So So this minus 1, when the 6 is distributed, takes off those 6 miles that you would have accounted for. So you could have written 6w minus 6. That works. Okay? Or 6 times the quantity w minus 1. So this is how long you've been traveling for. This is how long your brother has been traveling for. This is the rate your brother was traveling times how long he's traveling for. This is the rate you've been traveling times how long your brother is traveling for. If I want to know how far apart you are, what should I do with those two expressions? Add them together. If I've traveled 20 miles south and Sarah's traveled 10 miles north, we're 30 miles apart, are we? 20 down and 10 up, you add them together. So add these two expressions together. And if you think about it, it makes sense of the answer. And Ego already kind of pointed it out here. Look at the answer. 14W. Where does the 14 come from? 8 plus 6 is the combined rate, because you're separating. Why is there a minus 6, Will? Why would there be minus 6 in this problem? Because the person who was running at 6 miles an hour didn't do that first hour. Very good. So if you went for like 20 hours, so did your brother, so you can combine those rates, but he didn't do the first hour. So you got to subtract that 6 at the end. So this is the first hour missed by your brother. This is however far apart you would be after 14 hours had you both run from the beginning. If you both started in the beginning, I can just get rid of this minus 6. What if your brother started 2 hours later? Instead of minus 6, what would it be? Minus 12. If your brother started 3 hours later, this would be a minus 18, etc., etc. All right. The last all right, good timing. The Mathletes Club of Loyola has 26 members. By the way, the Mathletes Club meets tomorrow during activities, if you're interested, during the first half. There's a competition, actually, I think next week already. So if you like math and you like problem solving, I'd definitely get into it. That's what I did. You know, I did sports and math and science and stuff in high school, but academics are awesome, so definitely consider Math Club. Science Club also meets tomorrow during activities during the second half of the period. Do you guys have anything for peer leaders tomorrow or something like that during activities? No. You do or you don't? Okay. So first half Math Club, second half Science Club. If you're interested, either one. I do Science Club, Mr. Joseph, and Mr. Linus runs the Math Club. Okay, both are awesome clubs. You'll like both if you're interested in this stuff. So the Mathletes Club at Loyola has 26 members. The number of boys is 4 less than twice the number of girls. How many of each student of each gender does the club have? Give me some starting point, please. Christian, what's my starting point?
You get the number of boys, X.
All right. Let X equal the number of boys. Okay, and the number of boys is equal to what? 4 less than? Yeah. So, Christian, I'm going to rephrase that and say we don't know X. We don't know the number of boys just yet. Let's define X as the number of girls because we know what the boys are in terms of girls, right? If we call the number of girls X, then the number of boys is 4 less than twice that number. So what would the expression be that represents the number of boys? What would the expression be that is 4 less than twice the number of girls? And twice the number of girls. Alex, what do you got?
2x minus 4.
Yeah, the number of boys is 2x minus 4. Does that make sense why I restated the let statement? Okay? You might start with x equals the number of boys, but once you read the problem, you recognize, well, they kind of tell you that there's 4 less than twice the number of girls, so let's call x girls, so we can talk about boys with respect to girls. Okay? Now, I also know that there's 26 members. 26 members. So make a statement from that. Give me an equation I could use to represent that fact. What statement can I make to represent that fact? Jeffrey?
3x minus 4 is equal to 26.
Good. So the sum of these two quantities is equal to 26. And then what should I do? Everybody? Yep. And in general, just solve. If x is 10, what does that tell me? How do I know what that represents? Where do I find the representation for x, Will?
That's the number of girls.
Yeah, x is the number of girls. There's 10 girls. So you don't even have to plug it back into the let statement. Just say 10 plus what gives you 26, right? So how many boys are there? 16 boys. And you can take that 10, plug it back in up here. You'll get 20 minus 4, which is still 16. Or you could just say to yourself, if there's 26 people total, and you know there's 10 girls, then there must be 16 boys. Or vice versa. Okay? That makes sense? Alright. So, let's go over what we got for the next few days in the last minute of school here. Tomorrow is day 2. Do I meet with you guys on day 2? Don't think I do, right? Okay. So I don't meet with you on day 2. So on Thursday, which I'm going to see you next, it's a C day. Homework 1-8 is going to be due. Okay, on Thursday. Now, on Thursday we only have 32-minute periods. So, Thursday's a review day. Because Friday there's no school now. Originally Friday was a review day, if you remember. Thursday is review. Give me a minute. Thursday's review. On Friday, I'm going to make your prom sets due by electronic submission. If you plan on giving me a hard copy, and you already started the prom sets from 1-1 through 1-8 are due on Friday. So if you're giving me a hard copy, you can physically give it to me on Thursday. If you're not done on Thursday and you're doing a hard copy, you need to take pictures, scan the PDF or Genius Scan or Cam Scanner. But PDF is one document and submit it to Dropbox still. So Friday, I put like 5 p.m. to give you most of the day Friday to work on, you should have off. So if you're behind a little bit, get caught up in the next few days. On Monday is your first test. Sections 1-1 through 1-8. Is that clear? Thursday what? It's probably regular time in the end still. Probably like 2:30ish, maybe a little earlier, but that's about it.
On Thursday, we get out early, but we stay in and watch.
Is there any homework?
So we're not really out for that.
No.
Office hours are tomorrow morning if you need to be there. Don't forget.
Wait, there's practice, right?
7:35 start. Right on 8:15. So I recommend coming before 8:15. So maybe probably like 7:45.
So these problems are due on Thursday? Yeah.
We haven't reopened by like 7 probably, but if you get earlier,